Hello there! The part 8 of our Godot 4 tutorial is here. The game we've been creating is pretty advanced now. Objects explode, the player's ship breaks down into modules, we already implemented shaders and particles. But the ship looks too vulnerable, as you've just seen, as it gets destroyed on the first hit. Let's make it more interesting by adding a shield and calculating the hull integrity correctly. We have already prepared a shield power gauge in the heads-up display indicating the ship's shield strength. Now it's time to implement a basic shield mechanism that will provide protection against enemy attacks. Let's start with opening the player's scene and adding a new child node to the root node. Child node would be area 3D. We will rename it to shield. Okay, right-click shield and add a new child node, mesh instance 3D, and we will rename it to sphere. Okay, now we need to assign a new sphere mesh to this mesh instance 3D. Here it is. Let's click the mesh and change its values to fully encapsulate the ship. So the radius, let's try 1, not enough, 4, a bit more, let's try 5, even more, 6, okay, and the height 12, let's suppose this is correct. Radial segments, rings, it can stay as it is. Now we need to fix the material. Let's select a new standard material 3D, click the material, and we will activate the transparency to alpha and change the albedo color. Let's try something like light blue. Okay, not bad. And we need to change the alpha value here. Yeah, this looks like a shield, doesn't it? One more thing, let's set metallic to the maximum value just to make it shine a bit. Let's right-click shield and add another child node, which would be the collision shape 3D. We need to shape its property. We'll set it to a sphere shape, of course, and click it and set the same parameters like we did for the mesh instance 3D. So I think it was 6. Yeah, that's correct. Very well. Now we select shield again. Let's go to node and signals, and we will implement signal area entered. Double click, connect, and a new function on shield area entered has been generated in player GD. So yeah, we have successfully created and set up the shield, but of course at present it doesn't have any functionality. To enhance the collision calculation process, we will now focus on improving its implementation. From now on, whenever the player's ship encounters a projectile, impact, or collides with an enemy object, we will appropriately reduce the shield power. Once the shield power reaches 0, we will proceed to subtract the inflicted damage from the hull integrity until it drops to 0 and the ship gets destroyed. Yeah, it's simple as that. Let's add the following variables to the script player GD. Var max hull integrity is 100 and hull integrity is equals to its max value at the start. Okay, let's do the same for the shield power. shield. Okay. And we'll implement a new function. We'll call it process hit. Let's put it here. Func process hit area enemy impact. This is simply a switch to determine whether we were hit by the enemy object or just an enemy shot. It will be true or false. Okay, let's get the value of the impact. We will call it from a new function get hit points area enemy impact. Okay, not there yet, of course, but we will add it soon. And now calculations. If shield power is positive, there is still some shield, we will call the function shield a hit and pass the value, so we know how many hit points we should deduct from the shield power. And of course we need to send a signal to the main script. We will call this signal update add heads up display and emit. I think it might be better to add these temporary things to the script so we don't get so many errors in the editor. So first we will add a signal update HUD with no parameters, and we will prepare the function shield hit with the parameter value and just implement it because it is a one-liner. Shield hit, nope, shield power, of course, minus equals value. That's it. Okay, let's proceed. Now it's time to check if the shield power dropped below 0 or is 0. So if shield power less or equal to 0, negative shield power. Point is that if the value is negative, we should just use this negative part to be deducted from the hull integrity instead. That's why we inverted the sign here, and the shield should be removed. Yeah, another function which we don't have yet. Let's add it here. Func remove shield, no parameters, and we will simply just set the shield power to 0 to reset the possibly negative value. And we need to disable the collision, otherwise the collision shape 3D would be still accepting the hits and the events area entered, which we don't want to do if the shield is not here, and we must do it in this way. First, we should add these variables here, so we will just drag the shield itself with control and the collision shape as well. Collision shape 3D, I think the better name would be just shield collision. Okay, now we can use them, and we will call shield collision set deferred, disabled, true. I will explain this special call after we finish our code, because it is something that is very useful in other parts of the code each time we receive an asynchronous signal from another part. And of course, shield should be no longer visible. False. Okay. Where were we? Yeah, here, remove shield. So let's continue. And now we need to check again if the shield power is below 0. And now it's time to reduce the hull integrity. Let's subtract the value, and again we need to update HUD emit. Okay. Now let's check if the ship still has something to work with. If hull integrity equal less or equal 0, it seems that there is nothing left, so we will send a signal player destroyed. And it's time to distinguish between enemy impact and bullet impact, because if we collide with enemy, it's necessary to make the enemy explode in case we survive this impact. So if our hull integrity is positive, destroy the enemy. Or else we just call Q3, because in this case we were hit by a bullet and bullets don't explode. Okay, and finally we need to implement the missing function get hit points. Let's do it here. Func get hit points area enemy impact, and we will just return area life cycle hit points if enemy impact, else area hit points. So what's the point of this? Bullets don't have life cycle. They simply go until they hit something or leave the screen. So we take their hit points from the bullet object, but we know that enemies are bound to its life cycle, to their life cycle object, so we take it from here. Okay, and now we need to call the new function from both area entered functions. Let's remove this because we won't be destroying player on the first hit anymore, and let's add a new code var bullet impact area is in group bullet. So this means that we're hit by an enemy bullet, and enemy impact the same. Let's check another group, which would be a enemy. by the way, this is probably not fully correct because we already used the group bullet for our shots. So let's make it a bit different. Let's call it, for example, UFO bullet. Okay. And now, if we were hit by the first or second object, let's process the hit with parameters area and enemy impact. And we will do exactly the same in the other area entered function. Okay. So let me explain just what I didn't explain before. We introduced a new signal update HUD, but it doesn't do anything yet because the signal is unconnected and unimplemented. We will address this matter shortly. Now, once the shield is depleted, we employ the function setDeferred, where it is here, on the collision node to disable it. This approach is necessary because the signal area entered is received asynchronously. So, consequently, the remove shield function is invoked outside the frame update, which requires synchronization through this method. Trust me, if you don't do that, you will most likely get an error from Godot or some unexpected behavior. And yeah, I think that's all. I believe I explained everything else. If not, please don't hesitate to ask a question in comments. I will gladly explain the rest. Now we need to connect the signal and implement the callback function in the main script. So let me just copy the signal name and switch to main GD. And here we first need to make a reference to the heads-up display object. So where it is? No, we must click here to the main scene and just drag it here with Control. And in the function ready, we will connect the player to the signal. Player connect, and the name was this one. And let's add the function reference, callable self underscore on update HUD. Okay, the function must be implemented as well. Let's put it here, func on update, no parameters, and we will simply call the HUD object and the function set player values and pass the player. The function is not there yet. I will just add it right now. So let's open the heads-up display script. We don't have any. Okay, let's create it first. And now we need to make references to both progress bars. First, Control, and second. Now we don't need any of these standard functions. We will simply add our functions. Func set player values player, and we will do a nice trick to make it a little more smooth than just change the value of the progress bar. Let me prepare the function first. So I will just write pass here and implement the second function. Func tween property element property value, and what do we do here? If value is not element get property, which means we will call the rest only if the value changed, var tween is get tree, create tween, and tween property element value and 1. Okay, looks a bit confusing, right? You may be wondering why I utilized something called tween. Essentially, in Godot, the tween functionality serves as a means to implement basic animations without the necessity of including and configuring an instance of animation player. In this context, tween is employed to smoothly animate the progress bar's visual representation as it transitions to a new value. The animation occurs over a duration of 1 second. This is this one value. And by utilizing the tween, the visual effect is more visually appealing, of course, compared to instantly setting the bar size. We will see it in the game very soon. Let's just finish this code. So we'll call this new function tween property, player whole integrity. Yeah, of course, I need to rename these values first because we will in the future have another hull integrity and shield power of the boss enemy. So right now let's distinguish between these ones, player and player, just to get ready. Yeah, I know there is a typo. I think we can fix it here. Oh, where is the rename? Here. Is that correct? I suppose so. So let's do it again. And okay. All right. So player whole integrity bar value and player whole integrity. This is actually the new variable we introduced in the player's object, so it always contains the right, correct, actual value. And we'll do the same with the shield power. So it should be player shield power bar value, and this time we want to use shield power. It seems we forgot to implement one function, and this function is actually explode in the enemy script because we call this function from the player script when the enemy that made the impact with us but we survived should explode. So I just added it. Let me show it again. Here it is. Just passes the call to the lifecycle, calling the same function. And now when we try to start a game and we collide with asteroid, we can see it was destroyed and the shield power decreased and decreased again, and it seems to be working. The color is not the best, but I think this is just a temporary shield. We will in the later phase replace it with a shader material, which would look a lot better. Okay, we know that the ship's movement is not entirely realistic. We have the engines only at the bottom part, but the ship can be moved in all directions. However, it would still be pretty nice to incorporate some form of jets. This will allow us to display an animation with slight touch of randomness. And to achieve this effect, let's create another particle system. So let's find the root node of the player's scene, right-click and add a new child node, node 3D. Let's call it Flames. And we will add another child node to Flames of the type GPU particles 3D. Okay, and let's call it left flame. By the way, I disabled the gizmo for GPU particles 3D because if it's there, it shows some ugly gray box, which is pretty, I would say, it's not nice. So I'll turn it off, and that's better. Now we need to move the left flame to its right position, so it should be right here. Yeah, that looks correct. Great. Now, of course, nothing is there yet because the flames are not configured. We need to address this issue and implement a lot of features at the right side. Let's start with setting draw passes. That should be here, draw passes. Let's expand that, pass 1, and we will assign a new quad mesh to this pass. Let's click the mesh, select material, and create a new standard material 3D. Let's click the material, and we will set a lot of properties here. Start with transparency, which should be set to alpha. Now blend mode, we want add mode. Shading, again, we should switch to unshaded. Vertex color, we want used as albedo. And albedo color, I think we can keep it as it is for now. Now billboard, billboard is here. Particle billboard, and keep scale on. We need to find the process material now. It should be somewhere here. Yeah, here it is. So let's create a new particle process material, and we already have some particles here. Now let's shape them a bit. We'll click the material. No, here, particle material, of course, and change the emission shape from point to sphere. That will be more appropriate for a jet engine. Now direction should be not X but Z. What did I do? Yeah, 0 and 1. Okay, and spread we will change to 0. Now gravity, there is no gravity in space, so we will just make it 0. Initial velocity, let's try 2 and 10, minimum and maximum. Angular velocity, that would be from 0 to 40, let's say. Linear acceleration, let's do it from 1 to 5. Now angle, we would do it from 0 to full circle, 360. And scale, of course, we need to set up the scale correctly, 0.1 to 1. Okay, I think we can finally do the color. So let's set some basic color. I believe that something like fire would be pretty well. Yeah, let's make it a bit okay. That should be fine, and we will create another gradient like we did with the sparks. Let's click it and click again. Let's set something similar. Maybe this. All right, and move this bars a little. And now we want to increase the amount of particles to 200, and of course decrease the lifetime to 0.3. Oh, it's starting to look like a flame, doesn't it? Last thing we need to change is the drawing to local chords and draw order to view depth, and that should be it. It looks like the flame is too big, so we will change, we will scale it down in transform. Let's try something Better? Yeah, I suppose so. Let's move it a little more down and we can check it out in the game. Yeah, looks like a flame there. I would say it looks like a flame. Very nice. But of course we have two jet pipes, so we need to create a right flame too. It will be very easy. We just duplicate the left flame, Ctrl D, rename it to right flame, and change the coordinates, the x coordinate, to the positive value. Here it goes. Here it goes. And let's give it another look. Yeah, pretty fine. I just removed the metallic plate from the wings and put it on the jets just for fun, and I think it was just too shiny and didn't look as cool as I thought. Okay, the last thing that we will improve in this video is to make a little better bullet that is being shot by our ship. At this moment we are just moving a white pencil, which is not too visually appealing. We would like to add a trail effect. An effective approach to create a trail for the bullet would be to involve utilizing a particle system once again. Just take a look what we managed to do with jet flames. However, in this case we encounter some additional challenges. For example, a bullet moves much faster than any other object in the game, so to make a trail that would look consistent and solid, even if the game's FPS, frames per second, drops, would be quite difficult. So in this case we have another solution, and the solution is called Line 2D. Yes, exactly, we are going to utilize a 2D element in our 3D scene. Let me show you how it can be applied on our use case. So we will open the scene bullet tscn and add a new child node called Line 2D. There it is. We will rename it to trail. Okay. As it is a 2D object, it won't appear in the 3D editor, so instead we will position it and shape in the script. Let's attach a new script here called, wait a minute, okay, bullet trail. Bullet trail, okay. And instead of drawing a basic solid line, we have the advantage of using this Line 2D object, which offers various properties to create a visually appealing and dynamic trail. By incorporating a color gradient and customizable joints, we can adjust it to match the speed of the parent object and the game's frames per second, resulting in an, I would say, attractive visual effect. So let's start with a basic disappearing trail for this simple bullet. Let's add an export variable to customize the gradient and another one to set the minimal distance between the line points. And we will also implement a random element to the trail shape and call it wilderness. So let's do it. Export var min spawn distance. Let's say the default value would be 5. Now export var wildness. It would be set to 3, so we don't make too wild trail that would look unnatural. And export var gradient color, which would be set to just an empty gradient. Okay, I made these variables with the annotation export, so we can then easily change them in the inspector when we will make our attempts to fine-tune the appearance of the trail. Now, to actually implement the line object, we will take advantage of the built-in functions of line 2D to obtain the current number of the line points and to add a new point along the trail. So we will need something to remember the thickness of the trail over time. Let's call it point H, and it would be an array growing over time, starting with a 0 value. Now we need some more variables. Tick speed, which means how often we would like to add new joints to the trail. Tick is 0, just a variable to remember the current value, and wild speed 0.1. Very well, let's proceed. We don't need the function already, but we definitely need the function process. And in this function, let's implement the trail creation. So if tick is greater than current tick speed, let's make it 0, and now we'll iterate over the current number of joins. So let's make a cycle for p in range get point count, which is an internal function of the object line 2D. Point h p increased by, let's say, 5 multiplied by delta, so it's consistent regardless of the current FPS value. Now we will apply the wildness var rand vector is vector2. We are in the plane, it's a 2D object, and again we will do some random value from the range. Negative wild speed, positive wild speed, and the second parameter would be the same. We can copy and paste that. Okay, and we need to assign the new value to the point, increased by rand vector multiplied by wildness multiplied by point HP. So the trail will become thicker after some time, just like a smoke trail. I would say gets thicker as the smoke just is being emitted in all directions. Okay, that's enough for this branch. Else tick is increased by delta. Very well, and we need to make a new function, add new point that would be called at the time of initialization of this object, point position, and at pos is by default -1. Okay, and now if get point count is greater than 0 and point pos distance 2. This is a standard Godot function that measures the distance between two vectors. So point get point count -1, because arrays always start at 0 index, as we know, is less than min spawn distance. I think I misaligned the brackets. This is correct. Is it? Yes. Let's do nothing. Because we don't want to add new joins unless the minimal spawn distance is reached, of course. And if we get to this point, let's set point h. Let's add a new value to the array point h, which starts at 0 again, because every joint has its own history. And finally, we will add new point, which is again a built-in function of the object line 2D, point pos, and add pos. Okay, yeah, we should be done with this script. And the trail's lifetime is actually very short because we won't want to fill the game area with too many lines after the player picks some kinds of fast multi-shot power-up. So, and furthermore, 2D objects are always displayed on the top of the 3D scene. So we would risk covering important objects by a swarm of line trails if they don't quickly go away. The lifetime won't exceed 1 second, and we will use a twin object to make it slowly disappear right after the line is drawn. So I wasn't right in the beginning, we actually need the function already, but before we add that, let's add 2 more export variables. Export var lifetime min, let's set to half a second, and export var lifetime max would be 1 second. Okay. Now let's re-add the function already. Okay, and here we need to assign the gradient, of course. That's what I forgot before. Gradient, no, with lowercase g, because it is field of the line 2D object, and we will assign it to our gradient color. And we need to clear all existing points, which is just a failsafe, but it's possible the trail is probably created by default with at least 1 join, so we don't want anything there. And we need to stop it instantly. Why do we do that? Because the function stop, which we are about to implement, would use the tween as I suggested, so it will take this 1 second to disappear, which is why we call the stop instantly after creating this object. Let me show you func stop, and just like we did with the heads-up display, we define a new tween, get tree, create tween, and we will activate the 1 second animation tween property applied on this object, so that's why it's self. We want to modulate the alpha value to slowly make it fully transparent and then get rid of it, starting at 0 and randf range from lifetime min to lifetime max. So we would give some randomness to the appearance of the trail for every bullet. That should be enough. And now we need to call, just add some additional parameters to make it look even better. Let's do this tween trans circular. And how about this one? Set ease, ease out. This is just a visual improvement, and the trail will disappear in a more smooth way than just if we do it without these additional parameters. Okay, the script is finished. Now we need to call the function add new point from the original bullet GD script. Let's make a reference to this new node first with control, and I'll call it just bullet trail. Okay, and in the function process we will add a new function here, bullet trail add new point, and now we would like to transfer 3D coordinates to 2D plane as a projection. We can do that directly in the code, but I have a feeling that we would use this function in many other parts of the game. So let's suppose this function would be added to our game manager, and we will just prepare it here. Game manager to 2D and global position of this bullet. Global position. And now we need to implement it in game manager. First, we need a camera, because there is no projection without a camera. We will add a new variable called camera and a new function set camera as camera with an underscore. Camera is camera. Okay, and finally the function to 2D we prepared. Let's put it here, for instance, func to 2D and vector 3 as a parameter, and there is a simple camera function, return camera on project position vector 3. That could be okay. And the final step, of course, we added a new function that is supposed to be called from the main script. So let's open main GD. Here it is, and we will add a reference to our camera. So we need to switch to the main scene. Where is the camera? Here. Okay, control drag. Camera 3D, I think we can just call it camera. And in the function ready, we will set game manager, set camera. Okay, let's start the game and verify the trail. Yeah, I think you can see it, that the bullet is followed by a trail which is disappearing, and it is working as expected. But of course, it might be better to do it a different color than just white. We can make some experiments here. So let me switch back to the bullet scene, and we have the trail object here and the parameters. So we will change the gradient color to a new gradient, and let's try something different. For example, yeah, let's make it red. It could look nice, and modify just these values and start again. Yeah, red trails, definitely better than the white ones. Okay, thank you for watching, and next time we will finally introduce a system to creating levels in our games, full of enemies, wave of enemies, and all other things that are expected in a good arcade game.